a medical tool manufacturer in Chiba Prefecture. This is the room where they package their products. They're sealed in these pouches and shipped all over the world.
こちらになります。
Surgical needles with the thread pre-attached. Different sizes have different uses, but the one at the top here is only 30 microns in diameter, 0.03 millimeters, the smallest in the world.
米粒と比較していただけるとその小ささがよくわかると思います。
The rice is about 5 millimeters long, so the needle is truly tiny.
本当に小さくすぎて、例えばもうエアコンの空気とか、もうちょっとした空気でもう飛んでしまうような小ささです。
Our story begins back in 2001. Japan was one of the most medically advanced countries in the world. Advances in the field of microsurgery were occurring. Damaged tissue could be repaired using healthy tissue from another part of the body, with blood vessels being connected while viewed through a microscope. Such delicate operations required great skill and special equipment. A manufacturer in Chiba commanded a large share of the market for needles used in microsurgery. The company started out making clock hands, but moved into the medical field in the 60s. They continued to develop their surgical needles over the years. Then, one day, the company received a call from a doctor at a university hospital. "I want a smaller and thinner needle," he said. "Can your company make one for me?" Microsurgical techniques were advancing and small blood vessels were being connected. The needles the company made only worked for blood vessels that were at least 0.5 millimeters in diameter. Any thinner, and surgery could not be done. This gave rise to medically underserved populations. This is Kono Junichi, president of the company. Here's how he remembers things.
There was a population that couldn't have surgery done because the blood vessels in the affected area were too thin. We thought we should use our company's skills and passion towards finding a solution. We weren't thinking about profit or the numbers.
The company wanted to eliminate this medically underserved population. Kono decided to immediately start development of a new surgical needle. Development of this new needle was to be led by experienced engineer Iwadate Tsutomu. Since joining the company, he'd worked on the production process for surgical needles. Developing the new needle was an exciting prospect.
I thought we'd give it our best shot. It was a chance to see how small we could make it with our technology. Honestly, though, it was a bit daunting.
Iwadate got straight to work. The first order of business was seeing how thin the needle should be made. The body is filled with blood vessels. Certain vessels have an inner diameter of 0.1 millimeters. In order to suture these, the needles had to be 0.03 millimeters, less than a third of the inner diameter. But 0.03 millimeters had never been done before. How could such a tiny needle be made? The company looked towards this stainless steel thread. The thinnest thread that was made was 0.05 millimeters. If this could be made even thinner, perhaps it could be used for the needle. The first method that was attempted was electropolishing. The stainless steel thread is placed in a special solution. Then a current is applied. Through an electrolytic reaction, the surface of the thread is dissolved. But a closer look at the surface of the thread revealed a problem. The reaction worked, but it created a bumpy and uneven surface.
It came out bumpy. While it was thinner, it wasn't an even shape. It had peaks and valleys. I'd have to find another way to get it to 0.03 millimeters.
Was there another method? Iwadate fervently researched his options, and then a thought. Iwadate prepared 2 blocks. The stainless steel thread would be placed in between, and then rolled. After repeating this motion, the thread inside snapped. But had it become thinner? Iwadate put the thread under the microscope. Upon close inspection, a section had become 0.03 millimeters. That piece could be cut out and used to make the needle.
If I had about 3 centimeters, I could make a needle. I could tell that much just by looking. I checked by eye, measured, and thought it was good.
Iwadate removed the usable portion, but he soon ran into another problem. How could the tip of the piece be sharpened? If it wasn't sharp, it wouldn't work as a needle. But the thread was thinner than a hair. So what could be done? Iwadate had hit a wall. How to sharpen the tip? Some kind of grinding tool was needed. Iwadate created his own custom grinder and tried the thread on it. Then he viewed the tip under a microscope to verify the shape. This process was repeated over and over again. Finally, one day, the tip appeared sharp enough under the microscope. But would it work? He tried the test piece on some paper. It cleanly pierced the sheet.
Watching the action through a microscope, I could see it slip right through the paper. There was no resistance. That was when I knew I'd done it. It could be used as a needle.
But just as he was about to celebrate, there was one more hurdle to overcome: how to thread the needle. The surgical needles are shipped out with thread pre-attached. Until then, a laser had been used to open a hole for the thread to go into. But at only 0.03 millimeters, the laser would melt the back of the needle instead. Iwadate searched diligently for a way to attach the thread. He came up with something to try. He would use a press to flatten the end of the needle. set the thread onto the surface, and then pinch it all together. Iwadate activated the press. The end became less than 1/100th of a millimeter thick. Looking through the microscope, he pinched the thread on using a set of tweezers. Was it secure? He gave the thread a tug. And it slipped right out. The issue was the mold used for the press. The needle is set in this cavity and pressed from above. But this shape proved too loose to hold the thread. Iwadate had an idea to add grooves. The thread would embed the grooves after being pressed in. Adding required days on it to shape a mold. But even after many tries, the thread failed to catch in the grooves. This was going to be a marathon. Iwadate prepared himself for the task. He would stay over at work, dedicating his time to making the adjustments.
Things weren't going smoothly. I worked day and night, sleeping in a sleeping bag on a piece of cardboard. It was a matter of mere decimals, a few microns here and there on the mold. I kept on adjusting.
Finally, the mold with the grooves was complete. If the thread still slipped out, then the dream of the world's smallest needle would be over. Nervously, he pinched the end closed and pulled on the thread. The thread was secure.
It was finally done. What a process it had been. There are cases of infants or toddlers losing a finger in household accidents. But with a needle this small, they could get surgery. It could really make a difference.
And so, in 2004, the world's smallest surgical needle was finally finished. It was first used to reconstruct the palm of a hand, suturing blood vessels only 0.3 millimeters in diameter. After this initial success, other hospitals in Japan gradually came to adopt the needles.